All right, so the last lesson that we're going to do for this unit is revisiting substitution. So when an expression includes variables, which is what we call letters, this is anytime you see X, Y, A, B, etc. That is the part where most people claim math starts to get scary. We can evaluate the expression though if we're given the numerical value that that letter represents. So variables are essentially placeholders. Just going to write that over here. There are times where, say, you're planning a party and you want to know how much it costs for so many guests. You can come up with a mathematical equation using a placeholder for your number of guests. This way, you can calculate the answer no matter if that number changes or if that number stays the same. It makes it a little bit easier when you're using a mathematical calculation over and over and over again, where only one number in it is changing. Now, we can evaluate the expression, which means what is it actually equal to if we're given what that variable stands for. So we see this regularly in formulas that we use, and this is what we call substitution. So in example 1, I have to evaluate 4k minus 3 when k is equal to 2. So when we do this, we are going to substitute 2 for k, which means I'm going to replace the k with a 2. So in this case, I will get 4 times 2 minus 3. The analogy I often give students in class is if I am getting a, say, double coffee from Tim Hortons and I'm substituting the cream for milk, it means you are not giving me cream, you are giving me milk. So if I'm substituting 2 for k, you are not writing k, you are writing 2 in its place. Now we just have to go through BEDMAS. 4 times 2 is 8. Minus 3, because multiplication comes before addition and subtraction. 8 minus 3 is 5. So when k is equal to 2, that mathematical operation is equal to 5. Now, if k is equal to negative 2, I would do the same thing for replace my k with 2 or substitute my k for 2 minus 3. Again, multiplication comes first because of BEDMAS. 4 times negative 2 is negative 8 minus 3. Now I'm going to do my subtraction. 8 plus 3 is 11, and it's negative because they're both negative. So I will get negative 8 minus 3 is equal to negative 11. If I move on to example 2, the only difference is I have 2 variables, but I am still given what both variables can be inputted for in numerical values. So in this case, I'm going to get 12, replace 5 for A, and replace 6 for B. So I'm going to substitute them. 12 times 5 minus 6. This will give me 12 times 5 is 60 minus 6. And this is 54. If I look over on this side, I'm going to do the same thing, but when A is negative 4 and 12 is B. Oh, sorry, B is 12. So I will get 12 times negative 4 minus 12. This is going to give me 12 times negative 4 is, I want to say, negative 48 minus 12. Which means subtract another 12 from that gives me negative 60. So we can see how changing those two values did change what the same exact equation was equal to. Now we are going to do one last example where we have some brackets and exponents as well. So again, we are going to have to use BEDMAS, and this is when t is equal to 3. So that means I'm going to substitute both sections where I see t for 3. We'll get 4 times 3 squared. Keep in mind that this squared is not in brackets around the 4 and t. It means it's just t squared times 4. Minus 2. Keep in mind how here it is around brackets, so the 2 is included. Times 3 squared. First thing I have to do is my brackets. So I'm just going to go back here. 4 times 3 squared minus 2 times 3 is 6 squared. I then have to do my exponents, so 4 times 9 minus 36. I then have to do my division and multiplication. 4 times 9 is 36, minus 36, and then my addition and subtraction, which gives me 0. So my final answer is 0 when t is equal to 3. Now let's take a look if t is equal to 3 over 2. Again, I'm going to substitute this both times. So I will get 4 times 3 over 2 squared minus 2 times 3 over 2 squared. Now, one thing that you can keep in mind too is 2 is the same as saying 2 over 1. And that's going to help us out in a second when we do our brackets first. So first thing I'm going to do is just rewrite everything that's not in brackets. This is where it comes in handy. This is the same as saying 2 times 3 over 2 times 1, which gives me 6 over 2 squared. Now I am going to simplify this down in the next step, and what's going to end up happening is, 6 divided by 2 is 3. So this means now in my next step where I have my exponents, I'm going to bring my exponent through here and bring my exponent through to my numerator and my denominator, which will give me 4 times 3 to the power of 2 is 9 over 2 to the power of 2 is 4 minus 3 to the power of 2 is 9. Now again, when I move on to my division and multiplication, I'm assuming that that is over 1, so I can multiply by the top and divide by the bottom, and multiply through the bottom. So this will be 36 over 4 minus 9. 36 is divisible by 4. You could also see that. I realized a misstep. 4 and 4 cancel out. So this is actually just 9. And this is 9 minus 9 is 0. So we can see here too where two different values give us an equation that is equal to itself both times. And that is the end for the substitution lesson.